My name is Oleg Zhurakousky. I'm a long-time Spring engineer, currently leading Spring Cloud Stream and Spring Cloud Function project. And with me is Glenn.
Hey folks, my name is Glenn. I'm one of the engineers at Spring as well. I work on Spring Cloud Task, Spring Cloud Dataflow, Spring Batch, and when Oleg lets me, Spring Cloud Stream.
So yeah, today we're going to talk to you about Spring Cloud Stream, Spring Cloud Function project, and primarily actually Spring Cloud Stream, because that's the sort of the end result that you're going to see. But we're also going to touch a lot on Spring Cloud Function, which is means to an end, so to speak. But Spring Cloud Stream is one of the frameworks that I'm working on with Glenn occasional participation. And today our goal is to give you a quick preview into the framework, its features, and the benefits of using it in conjunction with another framework called Spring Cloud Function. So here's what's on our agenda. We are going to talk about streaming in general. What is streaming? We're also going to look at function as a stream handler. So basically, we're going to introduce you to the functional way of implementing various different requirements. At the very end, we're going to create an actually very sophisticated mutable stream based on one of Glenn's hobbies. And we're going to kind of, in conclusion, discuss what's new, what's upcoming, because we do have a release coming up. So to begin, let's establish the context for the rest of the talk and try to define what is streaming. So if you try to do it yourself or try to scour the web, you will see a lot of different definitions. We kind of, there's no clear definition of that, but so we kind of pick what we believe is most reasonable. And in this particular case, we like the definition provided by the guys from Hazelcast, which is event stream processing is the practice of taking action on a series of data points that originate from a system that continuously creates the data. So many different mechanisms produce these data points, which are also called events. An example of the delivery mechanism could be HTTP, messaging pops up, and so on and so forth, right? Event data typically goes through processing graph, a structure made of nodes and transition. A typical processing graph for event stream could be described as source, processor, or sink. Source is responsible for origin of the events. Processor is where the data is acted upon, and primarily where the developer spends most of his or her time, because this is where the business requirements are implemented. And finally, sink is where the data with a particular processing graph ends. The data is stored and sent to another system. Some alerts, some notifications could be sent out, and so on and so forth. So this is really the end of the processing graph, but not necessarily the end of the stream, because the end of the processing graph could be the beginning of the new stream somewhere else. So what is also important to understand is that source processors sync or decouple from one another, and are typically connected through some type of a messaging middleware, allowing you to build a very complex processing graphs relying on a variety of messaging and integration patterns. For example, you may want to add several processors or consumers to process data in parallel, or you may want to enforce a single consumer. You may want to have several consumers load balancing the processing power, and so on and so forth. So all that is achieved through applying these messaging and integration patterns. Speaking of messaging and integration patterns, they are all available in the enterprise integration pattern book, which you can see at the bottom right corner. And I would recommend that as a sort of a mandatory reading when it comes to streaming, event handling, and so on and so forth. So the boxes that we see on the screen identify high-level architecture describing patterns. We still need to somehow turn these patterns into some kind of executable code. And how do we do that? Like, what do we have as Java developers that allow us to turn these patterns into code? What strategies would we align these patterns within the available mechanism and strategies available in Java? Do we have anything already available? So to clearly represent source, processor, and sink. And the answer is yes, we do. It's called Java functions. So the three interfaces that were given to us since Java 8, which is a supplier, function, and consumer. Supplier is best suited to represent the source, since it defines no input but only output. Function is best, again, to represent the processor, because there's both input and output. So you receive something, you do something, and you produce something else, right? So this is, again, what I was mentioning earlier, is where developer spends most of his or her time. And finally, consumer is best suited to represent the sink, because this is really the end of the processing graph. It has input but no output. Note, quick, that throughout this demo, we'll be using the word function a bit loose because it implies that we're really implying that supplier, function, consumer is still a function, right? And technically it is. Supplier is a function with no input or with null input, and consumer is a function with null output, so to speak. So let's give it a quick look before we move on any further. But even before that, we're going to actually look at we're going to introduce you quickly to some of the tools that we're going to be using. Spring Boot. It's an opinionated framework on top of Spring Core. It provides for auto configuration patterns that are embedded into a jar, making your jar actually an executable piece of code. So in other words, by adding dependency to your POM, you're no longer just adding a library, you're adding a behavior. Spring Cloud Function, a framework which promotes implementation of business logic as Java functions, further instrumenting them to execute in the context of a different runtimes. And we're going to talk about this actually in a few minutes. And Spring Cloud Stream, finally, is a framework which instruments your function as event handlers bound to destinations using provided binders specific to a particular messaging system. So, for example, you want to have your function to become a message handler for Kafka using a Kafka binder. You have RabbitMQ using RabbitMQ binder, and so on and so forth. So we have a vast library of binders that you can use, and most likely you'll find one for your system. So, now, Glenn is going to do something exciting, and he's going to show you something very trivial, very, very fast, but very powerful because it's going to touch on the core pieces of everything we're going to be discussing today for the rest of the talk. So what Glenn is doing right now is he opens up a Spring initializer, which is basically a mechanism for you to start with any kind of Spring Boot application. And all I'm observing him doing, he's creating an application and adding some web ability and some function ability. We don't quite know yet what he intends to do, but we're going to see it in a minute. So now he clicked on generate, and he generated a project which he's about to import into his IDE. And as he importing it, I guess he called it what? To upper. So I'm going to assume he's going to write a function that's going to uppercase the string. Is that right, Glenn?
That is absolutely correct.
So a very trivial functionality, but like I said, one thing important to understand in this functional approach is that we really don't care at the framework level. We don't care what's inside the function. We only care about its signature. We only care about how to invoke it. So you are free to do whatever you want inside. So in other words, trivial or not trivial, it doesn't really matter to the framework. So what Glenn is doing right now, he's defining a bean of type function that takes string, outputs the string. He's calling it to upper. And note, this is on a brand new project, so nothing else was created other than the project structure, the dependencies, the POM file, and the template for Glenn to put his code in. So, okay, and return, and and return str to uppercase. Okay, now what we also want to see is, Glenn, can you show us the POM file real quick?
Will do.
So when Glenn was selecting, what project he wants to create, he selected something around web, so that added Spring Cloud Function Web and Spring Starter Web. So this was added to us by Spring Initializer, and as you can see, there's really nothing else in this project. So now go back to the code. What you see is a vanilla Spring Boot application. So in other words, if we don't have a prerequisite knowledge and knowing how to understand the dependency, we don't really know what this application does. But given the fact that we already do know that you added Spring Cloud Function Web, we should expect, and I'm kind of doing a sort of preemptive strike here, we should expect that this function somehow became a REST endpoint, that we can invoke this function over HTTP. Can we try, Glenn?
I think we're ready to rock and roll.
So what Glenn's going to do, he's just going to simply start this application. Like I said, the only thing he coded is the function right in front of you. There's nothing else behind the scene outside of usage of Spring Cloud Function framework. Okay. Now he's going to go to the browser and he's going to attempt to hit this function as a REST endpoint. So the URL for this is going to be localhost port, and then the name of the function, which is in this case to upper, and then the value that you wanted to send over. So, and as you can see, he sent hello SpringOne, and response came in as an uppercase hello SpringOne. But the main point here is that somehow the function that Glenn wrote, which is a faceless, contextless function, somehow became a REST endpoint. Very cool, Glenn. Let's try to do something else, Glenn. Let's go back to your POM file and let's say I want to turn this function into a message handler working with RabbitMQ. What do you think I should do?
I think we need to add a little Spring Cloud Stream. What do you think?
All right, let's try that. So we're going to add a Spring Cloud Stream Rabbit binder, which is basically a binding component that will that's responsible to bind user code to messaging system destination. In this case, the messaging system is going to be RabbitMQ. So, Glenn, can you show us the Rabbit console right now?
I think I can. And we will go there.
And we just want to verify that it's completely clean, that there's nothing out of ordinary in there. So it's like a vanilla. So now start the application again.
Okay, we will do that. And the application is rolling.
And go to the browser window where you REST endpoint.
The endpoint. Yes,
yeah.
I see what you're going. All right.
So try to execute it again.
And we'll say 2, 3.
Yep, and we got it's still working. So it is still a REST endpoint, but go back to the Rabbit console now.
Yes, I can.
And now we see something interesting here. So we have toOpper in, toOpper out, which is automatically the function based on the function name was turned into bindings that were auto provisioned within the RabbitMQ messaging system. And note, Glenn didn't do anything. He just worked out of the box, right? So he just provided a piece of code. So Glenn, can you send a message and see if the function gets invoked?
I think that's a good idea. And we'll say, hello, SpringOne. And we'll publish that message.
And can you go back to the console?
There we go. And we will go back to the console. Actually, it's right here.
And you can see from his console that the function was invoked with hello SpringOne. So all of a sudden, the same function that Glenn just wrote 2 seconds ago that was originally just a REST endpoint also became, remained to be a REST endpoint, but also became a message handler, all by just simply adding a particular dependency as auto configuration to the class path. Now, of course, for this trivial demo, then Glenn didn't have to provide any additional configuration because we simply rely on default, which is again the power of Spring Boot. As we're going to move along, we'll try to build something more realistic. Yes, of course, there are certain configurations that we can provide, but so what we have seen is a demonstration of how frameworks such as Spring Cloud Stream, Spring Cloud Function, and Spring Boot bring your raw business components functions into life by bringing different execution contexts with Spring Boot auto configuration. So,
well, I tell you what, with all this discussion of functions, I was wondering how we could apply this to our business case.
So you're going to talk about the business case?
Can we?
Sure.
Oh, sweet. So, folks, the actual business case isn't my hobby of kayaking. It's what I do before I go kayaking. As with any sport, the things that we want to do is make sure we take all the safety precautions beforehand. In this case, I have 2 manual steps that I always go through before I kayak. One, I check the weather. If there's going to be thunderstorms, rain, or heavy wind, I probably won't go out that day. But the other thing that I can do is I can also go out to the United States Geological Survey Waters Resources Division. From here, I can actually go in and check the conditions of lakes, rivers, and streams throughout the United States because they've deployed sensors on these bodies of water. These sensors tell us the amount of flow that's going through these rivers and creeks, as well as the height and in some cases even bacteria levels. The creek that we see here is one I love to kayak. It is about 1 meter high on average, and that's beautiful kayaking weather for me, or conditions for me. But as we see, there was a very bad thunderstorm, brief, but it raised the level of this particular creek from 1 meter to 3 meters, which is way beyond my ability to kayak with my current skill level. So with this, I have the ability to check before I even leave my home whether I can go kayaking or not. Now, looking at this and talking about functions, Oleg, do you think that maybe we can automate this?
I know in you, Glenn, I think you're actually setting me up because I think you already did that.
I think you might be right, folks. So with that, let's go out and take a look at what I did. Now, folks, remember, I love batch development. So I always think everything is an ephemeral solution, right? So I wrote just a straight up boot application that when I run it, basically goes out, hits the United States Geological Survey for 3 creeks I love to kayak, and then we can see that it generates a very small report. And where it actually goes in and will do one of 2 things. Beside each creek name, it will put a green check that says, Glenn, this creek looks like it's a pretty good condition based on your skill level, or it's going to put a red X, like maybe it's not good for you to go out kayaking that day.
So, what we see right now is Glenn provided a semi-automated solution. He kind of incorporated all these major 3 requirements into some piece of code, and kind of solved the problem he is facing. But as any other solution, they all have pros and cons. So in Glenn's case, his code does automate the process and provides the answer to the question he is looking for. However, it is a monolith, right? It's all or nothing proposition. Everything is jammed into a single class, single method. So he can only do the whole thing or nothing at all. And again, what would you expect from the batch guy with batch mentality? So it also provides only a single way of data consumption. So Glenn just prints out the log file, some kind of a report into the console. So introducing anything new would require a code change, redeployment, repackaging, and so on and so forth, right? So in other words, any kind of timely updates, the timely updates. Like for example, Glenn wants to, after 3 or 4 hours, check again. He needs to go manually again, rerun. So that's why I call it sort of a semi-automated solution. It does allow everything to be done quickly, but somebody has to trigger it, somebody has to manage it, maintain it, and so on and so forth. In other words, it is a semi-automated solution that is very sensitive when it comes to any kind of changes, introduction of new features, enhancements, and so on and so forth. So since we now fully understand not only the business problem, but also the issues Glenn is facing with the architecture of his solution, what can we do to make it more accessible, more agile, more user-friendly, more functional, so to speak? So let's look at Glenn's use case and break it apart into individual components. Again, we're not trying to build any kind of graph at this moment. We simply try to identify what is there that we can assemble that eventually into some kind of processing graph. So what Glenn already identifies is that there's a component that sources the data from U.S. Geological Survey website. So that's our source, right? We also have a processor which converts data from one representation to another for reasons that only Glenn knows, right? And we have a consumer which basically logs the data to the console, right? So that's based. Those 3 components based on the Glenn's current architecture, current ability of his application. What we're introducing is a few extra components, like one component that will, let's say, write what's sent to it to the database, and another component that will send SMS message to an address based on what was sent to this component, right? So, and that's pretty much it when it comes to component architecture, right? So now let's try to realize it within some kind of a processing graph. So, as I already mentioned before, so we have we're sourcing the data from U.S. Geological Survey site. So when it comes to functional mentality, we're going to align it with the supplier because that's really a proper mapping for something that is a source, right? We have a processor that is going to be implemented most likely as a function because that's, again, something that maps to a function really well. And then we have a consumer for the login, which is going to be or sync for the login, which is going to be implemented as a consumer. So what we have now is the copy, at least in the paper, of what Glenn has. But the difference is that this copy is made of 3 distinct and completely independent components that we can now orchestrate any way we want and apply a variety of different messaging patterns as well. So how do we do that, right?
Yeah.
So I guess we should look at the Glenn's application and see, first of all, what can we salvage, if anything, from Glenn's app. So what I would ask Glenn is to show us, for example, so we know what's going on between line of code 50 and 60, right? But what I'm interested is transformer creek measurement. How is it implemented? Oh, it's implemented already as a function. So that means that it will just save us a lot of time because now we don't need to convert it to a function because we already have a framework that is capable of recognizing functions, right? So, and consumer for his report is also a consumer, so which means a framework, again, was going to be very capable of recognizing it. So but again, Glenn has it all implemented in a single class, right? So the proper approach would be to probably isolate everything into sort of a library that we can add as a pure dependency to our future applications that we can reuse, right? And I guess you already did that, right?
Yep, sure did.
So can you show us this library real quick?
So we have the transform creek measurement right here as a class.
So you have it as a class. You have transform creek measurement. You have a few other things like repository for a database, and other things, right? So basically, Glenn has a library of functions. Okay. So now, I guess, Glenn, you already started building, as we discussed before. You already started building this. The newer solution as a source processor sync kind of pattern, right?
Sort of did.
Yeah. So I guess let's try to show what you already have. So what Glenn is showing right now is the consumer configuration class, which is basically defines a couple of the beans, right? But as you can see here, there's a bit more configuration elements present because we, for example, see something called conditional on property, which we'll talk about in a few minutes, right? But basically, he has configuration for 2 consumers and one function. Okay. In order to better understand what will actually happen, as I mentioned before, for this application, which is a bit more sophisticated than the uppercase that Glenn was showing you earlier, we need to look at the configuration. And here's the configuration. So first thing what Glenn did here is that he identified, because he has a configuration that provides several different functions, he needs to tell the framework which function he is actually interested in. And what you see here is actually another interesting feature of Spring Cloud Function, Spring Cloud Stream project is the function composition. So basically Glenn is saying, listen, I had a complex problem. I want to break this problem into a set of simple components that are addressed individually, and then I want to reassemble it at runtime. Can I do that? First of all, yes, you can, and that's given to us not by Spring, it's Java, through its typical Java composition. So all we did is provide a configuration marker to inform the framework that 2 functions need to be composed. So what actually is going to happen is that the generate report function is going to be composed with the log consumer. The byproduct of this composition is still a consumer, but now something will happen in the generate report, and then the output of that is going to go into the log, right? So his function definition is actually not function name. That's why it's called definition, because it's the result of this composition. So based on the function definition, framework will create an automatic binding, which is the part which connects the function input and function output to the destination in the messaging system. The default binding naming convention is basically take everything that was composed into a single name, and then we have in and out stands for input and output. Okay, so obviously when you have a lot of things you're composing, the name itself would be difficult to manage and understand. So what Glenn is doing here is simply mapping of something a complex name to a simple name that is easier to refer to. So in this particular case, he's mapping generate report log in 0 input binding to the word input, which gives him ability later on to refer to this thing as input in every other configuration. So, and last but not least, line 9, Glenn basically maps this binding to a specific destination within the messaging system, in this case, RabbitMQ. The reason why he needs to do this explicitly is because when we're going to build the processing graph, in order for the processor, source processor, and sync to interact with one another, they need to share some type of communication medium. So, which means that somebody has to send something to a destination from which something else will consume it from, right? So we basically, while components themselves are independent, they're sharing messaging destination.
Correct.
All right, so start it up.
Okay, I've already pre-compiled this, folks, and so let's kick it off, and it's running.
So obviously, once it's started, nothing is happening because nothing should happen because nothing is, no data is coming in. However, what we can do is we can go to RabbitMQ dashboard and look at the console and see if there was anything that was created for us. And you can see the Creek data exchange that was created because we started that particular application, right, which is responsible for creating this exchange, this destination. So now, I'm assuming you already have a processor going.
I might start the processor for us.
So again, can you show the processor first before you?
Absolutely. Let's go there.
So the processor, again, another Spring Boot app, just defines a function. And again, the important part is to look at the configuration. A lot of similar things here. We don't use function composition here. We're only relying on a single function. But again, function name is very long. Glenn just does the same mapping from the input to input, the output to output, and then you can see the destination Creek data, which is shared with the previous application. So now, Glenn, can you start this one up?
I think I can do
Again,
that.
he already has it precompiled, so he just hits it. So in a way, you can look at it. As you can see, he has 3 windows. So we're starting it from right to left. We are building it from right to left because technically, again, nothing is moving because the outmost left window shows nothing because we have not began sourcing the data. But what it also means, shows you another interesting thing is that your application is still functioning because the processor is ready to accept the data whenever it arrives on destination. So technically, Glenn, you don't need a source. You can technically go into the queue and send message manually if you wanted to.
Absolutely, I could.
Okay. So, all right. So now let's look at the sourcing app. This one is quite a little different than everything you just see because this one defines function as a supplier, right? So that's where the data is going to originate. Now, supplier is different than function or consumer. There's a different style of function because unlike supplier and unlike function and consumer, which are triggered based on arrival of some kind of an input, supplier doesn't have any input. So there's got to be some other mechanism that will trigger a supplier. And because remember, with Glenn's initial solution, he was the supplier, he was the trigger, he was the guy who pushed the button every time he wants to get an update. So in a streaming solution, we don't want to be those people. We want to have some kind of automated solution. So in the case of supplier and in conjunction with Spring Cloud Stream, the mechanism to trigger a supplier is the polling mechanism, which by default will poll the supplier every second, right? Mm-hmm. However, every second will risk us being rate limited with the US Geological website. So Glenn, can you show us configuration and see what you did? So Glenn slowed it down and made a 15-second polling interval, sure, right? But obviously for this application, even 15 seconds is too often. So, but again, we're trying to make it more sort of a demo friendly. But you could set it to 1 hour or 1 day, and it's going to be retriggered. So, all right, Glenn. Again, same sharing destination USGS data. So now you can see how the 3 applications are now connected through this destination. So now, once we start this one, we should expect some kind of a flow going through processor and the sink. And that's what happens. So now what we see is, besides the fact that everything worked, we see that right now, one lake, Glenn is kind of out of options. So he has one lake he can go to, the other 2 he better not, right? But you can see again, after 15 seconds, it reran and produced another report and so on and so forth. So quick recap. So what you have observed is the same process that Glenn showed us before, but right now this process is no longer monolith. It's built from 3 independent components that we can start, stop, and so on and so forth. So Glenn, just for example, can you shut down the processor?
Yes, I can.
So now what we have source running and a sink running, right? But the processor is shut down, right? Did something happen to application, Glenn?
I shut it down, but we're ready.
Down, but as a whole application.
Mm-hmm.
Okay,
yep.
So what will happen if you start the processor again?
It's going to pick up where it left off at. On the right, I just put some spaces there.
But you see the source is running because the source was still producing the data and was depositing it on the queue.
Correct.
Now the processor was not able to dequeue this data until it got restarted. But as soon as it did, it completely drained the queue, and we saw the reports right away. So we can do the same thing, start, stop with the supplier. We can do the same thing with the sink. So we can manage applications very independently.
Correct.
Okay. So like I said, each component is an independent application that could be managed and maintained in isolation. Each component should be individually tested because, again, each component is an independent function that really facilitates the better testing because its implementation does not leak into the context of execution because, quite frankly, when Glenn was developing a function, you could easily argue he did not know whether it's going to be messaging or whether it's going to be REST endpoint or what it's going to be. So the context of execution is brought up later. So application runs in scheduled mode. So there's no longer requirement to do anything manually. And we can right now we're just simply using a simple polling mechanism, but we can configure it with the cron triggers and any kind of more sophisticated triggers, right? Relying on our newly discovered ability to clearly separate functional versus non-functional concerns by applying messaging pattern as part of the application assembly, we get the added benefit of changing application state by adding or removing functionality to a live application. We haven't showed this, but we are about to. Okay, so now knowing all this, let's make our app more accessible and send Glenn, let's say, a text message, right? So Glenn, wouldn't it be nice if you would, like, instead of you, driving and running your app on the computer on the right seat, it would be nice if you just, it was safer if you receive a text message?
I think it would be great to know.
All right. So now tell me what would need to happen for you to receive a text message.
In this particular case, what I would do is actually change the definition.
So you're going to use the same consumer configuration.
Absolutely.
Can you show it to us again?
Yes, I can. We'll go right back over to here to our demo, and we will go back to our consumer. And instead of doing the generate log, we're going to use.
Okay, so you have another consumer here, which is a SMS consumer, which will be bootstrapped only if the value of the property sprinkler function definition is generate report pipe SMS. So which means you can go to this property file and change that, right? And start it again.
I could.
But for that you would have to recompile, rebuild, and everything else, right?
How would we do that?
So, but given the fact that with Spring, you take the properties provided via command line, take precedence over the one provided by application, you can effectively override and introduce change to the application without rebuilding it, right?
Absolutely.
So can we look at your command line?
I think we certainly can.
So Glenn is basically starting the same application, Greek consumer, as he did in the third window, except that he is now changing the function definition to generate report SMS. And what's going to happen is that we're just basically adding another consumer. But note, the application still is running.
Correct.
So hit it.
All right, let's hit it. And it's going to start up. We're going to show that data is still flowing to the other app. And we'll get a message in a second.
Yep.
And there we go. And
Glenn's telephone is about to beep because the data went out.
There we go.
And here we go. So Glenn received a text message that only one lake is available out of 3, but at least now it's no longer in the console. And what's most importantly is we just added a new functionality to functioning and, most importantly, running a live application. So can we technically shut down the consumer for logging and keep the SMS going, or the vice versa?
Absolutely. What do you want to do? Do you want to turn off the SMS so it doesn't keep buzzing my watch?
I actually want to do something more crazy.
Oh.
How about we'll shut down Rabbit?
Well, if you say so, I will shut down.
What will happen? Because you have right now 4 components bound to RabbitMQ.
So I'm going to stop my Rabbit instance. And now my Rabbit instance is shut down, and everybody's going.
I see all kinds of mess going on in the consumers.
But the apps are still running, Oleg. Look.
But I see the exception stack trace. Like, all right, what should we shut down and restart every app right now, or what should we do?
I think we should start up Rabbit again and see if we get our messages.
All right, let's try that.
And we're going to start it.
So we are restarting the messaging system, and
takes a couple of minutes.
Yeah, but all of a sudden, things starting to reconnect. I see, and
this is where
we can.
Yep.
Oh, look at that! So basically, not only you can stop a single individual application, bring them, and which actually allows you to do rolling upgrades, right? You can actually, the applications themselves and the flow itself was very well tolerant of the network failures or inability of a messaging system, because you didn't have to restart any of the apps. They just completely came to life on their own.
Yeah, I just actually shut down the application that manages the SMS. And the reason I did that was I kept getting text messages. But the interesting thing is, by shutting it down, guess what? The app for the console is still running. So I can mutate my stream here.
That's pretty cool. So, Glenn, what we have seen is by adding additional consumer, we've seen this consumer was basically processing data in parallel with the other consumer. But what if what if I want to introduce some type of load balancing? Basically, introduce consumers that will go one, two, one, two, one, two, sort of like imagining a very high load and a very heavy processing.
Mhm.
What can we do that?
I think so. I could start a whole new instance of the consumer configuration where we're just logging into console. Would you like me to
Let's
start
give it a
it?
shot. Yeah.
So in that case, let me go to the right screen.
So the first consumer is still running.
Yep.
Right.
And
We're just starting another instance of the same identical logging consumer.
same thing. So it's going to start up. There we go. And we will start seeing data load balance between the original and the new instance. So the
All
original.
right. So we just got the data in the first consumer, but nothing in the second consumer.
That's correct. And in another 15 seconds, we're going to actually see the data come into the second consumer as it begins to load balance. We may trim that.
Well, they will trim it.
Yeah, they'll trim it.
So now we get the data in the second consumer, but not in the first one. So we clearly see that the data is being load balanced. But I'm puzzled, Glenn, why it didn't work the same way with the SMS consumer. What?
Because we sent it to a whole different group. The group. Of
Oh,
the
so
SMS.
basically the concept of the consumer group has a lot to play in here, right? So because you started literally the identical instance of a second consumer, I'm assuming configuration is identical. So this consumer belongs to the same group, and now it entered into a competing consumer relationship with the other consumer, right?
Correct.
Which now becomes sort of a load balancing. It relies on a load balancing mechanism. The SMS consumer was most likely part of a different consumer group, and therefore was executing in true parallel fashion.
Absolutely.
So I guess with this, what we also see is that you can clearly, as we mentioned before, after addressing functional requirements in the body of your functions, and when you're assembling the application, you can now address various different messaging patterns through configurations, through things available within your messaging system without ever touching your code.
Correct.
All right. Well, I think what we have built, where we started and where we are right now, is a much better architecture. It's certainly flows better. It's certainly easier to understand, and most importantly, much easier to maintain, in my opinion.
Yes.
So let's recap then. So functions, which was a big part of our presentation, we hope you got that message. They help with business requirements. If you think about function, like in general, I always like to ask this rhetorical question. Like, think about requirements of past, present, or future, which could not be mapped to either supplier, function, and consumer. Chances are you will not find such requirement because, and I almost wish these three interfaces were available since Java 2, for example, and we didn't have to wait till Java 8 for that, right? But yeah, so it makes our life a little simpler because it also allows us, it defines for us a lingo to properly communicate, because by simply saying supplier, you're already communicating a lot about what this particular function is going to do versus consumer, for example, right? Thinking in terms of function also helps you isolate yourself from execution context, which often, which has tendency to sometimes leak into the functional code because you can't really like think about implementing something without knowing that it's going to come from message or whatever, from messaging system or from REST endpoints, so on and so forth. Now, when you purely think in terms of functions, you don't have execution context in your mind, nothing to pollute your mind with extra concerns other than pure functional concerns. So that helps to maintain a better, clean, reusable code, right? So frameworks such as Spring Cloud Function turn your function into, basically brings your function alive, like to life. It turns it into something within the particular execution context. And the Spring Cloud Stream is a good example of sort of like an extension to that notion, where it turns a function into a message handler in the context of a particular messaging system. When mixed into a single solution, you get a clean and easy to maintain code. The assembled application can be managed and mapped independently at the level of individual components, as opposed to at the level of one entire monolith, right? And of course, last but not least, testing. I hope you guys test the code, but functional approach into implementing business requirements actually keeps your execution, because it keeps you execution context free. It makes testing much simpler, which results in a better tested code, which basically results in a better code, right? So last but not least, of course, as I mentioned earlier, we're coming out with a new release of Spring Cloud Stream, Spring Cloud Function as part of the overall Spring Cloud, Spring Boot release, kind of end of the year releases. So of course, there is quite a few new things that are coming out with both Spring Cloud Stream and Spring Cloud Function. We would not be able to mention all of them, but few of the callouts would be, support for bifunction for those people who are already familiar with the previous state of the frameworks and how with the concept of a message which contains payload and headers. And if you want to receive a parsed result and without extracting it yourself, you can use bifunction, which allows you the inputs will be payload and headers. So that's some people find it very useful. Enhanced support for routing and filtering. Again, that support was added with version 3.2, but there's a lot of enhancement, a lot of new features with regards to routing and filtering. So again, that's all I can say right now, but you can read the documentation, reference manual. There's a lot of it was already updated. The big one is observability micrometer. So this is basically a way to look inside, to get inside of your application. So through micrometer observability that we provide within Spring 3.0. So effectively instrumenting your code to get insights. gRPC, our socket support within Spring Cloud Function. Spring Pulsar, which is, if you're familiar with Spring MQP and Spring Kafka, it's basically a similar project to enhance the Pulsar API, which eventually going to be used by Spring Integration and Spring Cloud Stream binders for Apache Pulsar. What else? Schema registry. Again, we had this sort of a love-hate relationship with the schema registry because at first we thought that nobody's using it. We're just maintaining something that is not worthy of our time. And as soon as we removed it, all of a sudden we start realizing how much we start getting feedback from the community saying, look, we're a schema registry. So again, that should tell you how important it is to actually communicate with us, what features you're using, what features you're not using, because if you don't know, we don't know. If you don't tell us, we don't know. And things like this happens. But never mind, the schema registry is coming back with 4.0, so everything's fine. What else? Multi-binder support for StreamBridge, another interesting component of Spring Cloud Stream. We didn't cover it today, but again, very easy to understand. And right now it works with multiple binders. So a lot of, again, on the Spring Cloud Function side, again, outside of scope of this presentation, but we turn your function into AWS Lambda, just like we turn it into a REST endpoint or a handler. And there's a lot of enhancements and new features when it came to AWS, including the newly announced AWS Snapstart support based on the Project Crack. So all these things are coming out with the new release of Spring Cloud Stream, Spring Cloud Function, like I said, the Spring Cloud. That said, I think we're done, Glenn. So where to find us? We are, here's the couple of GitHub addresses for the Spring Cloud Stream, Spring Cloud Function project. Stack Overflow, we have Spring Cloud Stream, Spring Cloud Function channels there, so you can ask questions there. We don't use Gitter. We did, but not anymore. So Stack Overflow for questions and GitHub for raising issues. We're always there to help you. Other than that, I think we're done, Glenn. I would like to thank you guys for listening. I wish it was live. Hopefully in the future it will be live. And thank Glenn for helping me out.
Thank you, folks. And if you ever want to take a look at the applications that we used, you can look at the bottom link and then work with those same samples.